Ladies and gentlemen, welcome for our fifth launch of the year from the Guiana Space Center, the second with Soyuz. For today's mission, Soyuz is set to deliver 4 O3b satellites manufactured by Thales Alenia Space into a circular medium Earth orbit located in the equatorial plane. This is the second mission to be performed here in Kourou for O3b, following the June 2013 successful mission. It will carry a total payload mass around 2.8 tons. It shall lift off at 3 hours PM 55 minutes and 56 seconds local. From liftoff until the first 2 spacecraft separation, the elapsed time will be slightly above 2 hours. The remaining 2 satellites will be released in a second step 21 minutes later. Tonight's mission highlights the versatility of our medium-sized vehicle, Soyuz. After the launch of Sentinel-1A, an Earth observation satellite, and before the launch of the first 2 Galileo Foc navigation satellites soon this summer, Soyuz is used today for a third application related to telecommunications with O3b innovating concept. I would like to thank warmly O3b Networks for entrusting Arianespace with the launch of this second batch of 4 satellites, which will allow to make the constellation fully operational. O3b Constellation is a major initiative to reduce the digital divide by providing high-speed, low-latency internet services for an affordable price to the other 3 billion of people located around the equator and so far badly connected or not connected at all. But our Soyuz is now ready for launch, so enjoy the show.
A very big welcome to you. We are live at the Guiana Space Center, and there's Soyuz on the pad undergoing the final preparations. On board, we have our 4 passengers, the next 4 satellites in the O3b constellation. We're just under 12 minutes to launch now. There's the countdown on the top right-hand side of your screen. This is mission control, and the operational teams behind me here in what we call the fishbowl behind the glass are concentrating hard at this point before launch. Our program comes to you in both French and in English, and in the French commentary box is Pierre Junier. Pierre.
Bonjour Katie, bonjour à tous. Eh bien, on va tout de suite présenter le lanceur Soyuz qui se compose de 3 étages. Le premier étage avec 4 boosters qui présentent chacun un moteur et 4 tuyères. Ces 4 accélérateurs sont assemblés autour du 2e étage appelé corps central. Enfin, le troisième
third stage of a mass of 28 tons. These 3 stages work with liquid oxygen and kerosene. At the top, you have the frégate, and then under the fairing, the 4 satellites of the O3b. And they weight 700 kilo. You could see them now with a total mass of the launcher, which is 300 tons. So this is the explanation of this Soyuz launcher. I give you the floor, Katie.
There of our launcher and indeed our satellites. So, mission control is actually the nerve center, really, of operations here at the base. And this is one of the key teams. This is the flight directorate. It's Arianespace top management, headed by Stefan Israel, who you saw there, the CEO of Arianespace. And these guys take all the final decisions should there be an unplanned situation. And that's Patrick Loire there. So a number of different teams, and the O3b teams here as well, of course. And we have both Russian and European teams for tonight because it's a Russian rocket. So over my shoulder you can see the status panels. Everything's green right now, so we are go for launch. Pierre, why don't you talk us through them?
Eh bien, le panneau des verts, vous savez qu'il reflète l'état de l'ensemble des moyens nécessaires au lancement.
You know that you have the status of the launcher, the base, the meteor. Everything must be green in order to be able to authorize this launch. So it's a visual equipment. It's like a traffic light, and it is displayed everywhere in the world. Everybody is informed on real time. It's a entirely transparent system. Katie, you have the floor.
O3b is really a pioneering network, a very important network, so I'm delighted that we have Steve Collar here to join us. Steve is the CEO of O3b Networks. Steve, what makes it so special? I mean, last year we launched the first batch. We were all quite moved, I have to say. What is it that makes the network so special?
Well, as you just heard from Stefan on the video, our name, O3b, represents the other 3 billion people who are not connected to the global internet. And we at O3b are re-engineering satellite communications. We're bringing them closer to Earth, which eliminates the delay, and we're driving down the cost. So we're delivering fiber-like performance, but with the reach and flexibility of satellite.
So it means that so many more people on the planet are going to be able to access high-speed internet. And as I said, we launched the first batch at Arianespace last year. We're going to launch the final 4 next year. So it's been a long journey, and Arianespace and also Thales Alenia Space, who built the satellites, have been with you from the start. How important is that relationship?
The partnership has been exceptional. We're working with the satellite manufacturer who has more experience in medium Earth orbit than any in the world today, and we're launching with the world's premier launch service provider. So we could not wish for better partners.
Well, I'm very pleased to hear that. Thanks very much indeed, Steve. Steve is going to be joining me in the commentary box, next to Pierre's commentary box behind the audience here in Mission Control for part 2 of the programme. But first of all, I'd like to hand you over now to a film, because of course you were talking there, Steve, about the teams having been played such an important role all together. And we're going to find out about the launch campaign, because many people have been on the base here now for the last few weeks. Once the different parts arrived in French Guiana, they were transported to the Launch Vehicle Integration Building, the MIC, where the first 3 stages were assembled horizontally, starting with the 4 boosters, which were strapped to the second stage, followed by integration of the third stage. Meanwhile, the 4 O3b satellites arrived at Cayenne's Félix Éboué Airport on the specially equipped Antonov plane and were then transported to the payload processing facility at the Guiana Space Center. Here, teams performed a series of tests to check the good health of the satellites in the utmost cleanliness. They were then sent for fueling operations before attaching the 4 of them using a special dispenser system. The dispenser and the satellites were then transferred to the O3b building, where they were integrated into the frigate upper stage. The whole thing was carefully hoisted and encapsulated inside the protective case of the fairing to form what's known as the upper composite. After a series of review meetings, the first 3 stages of Soyuz were then transferred horizontally to the pad on its launch table. The vehicle was then raised to a vertical position inside the mobile gantry, which protects it and provides feed lines until it's retracted 1 hour before launch. The upper composite, that's the fairing and the satellites, frigate and the dispenser inside, was then transported to the pad. There they were hoisted on top of the Soyuz and mated with the third stage that same day. The fluid and electrical connections were then activated along with the air conditioning inside the fairing. So I've now come upstairs to the commentary box, where I shall be hosting the rest of the programme. And we are coming up to a key milestone in the launch. It's the automated sequence for Soyuz, which started around about an hour and a half ago, but we're now entering the final phase, the last 5 minutes. It's called Kluch na Start. Kluch is key in Russian. Here at the CSG, there isn't a key, it's largely symbolic, but at the Russian Launch Control Center they actually do turn a real key to start the synchronized sequence. So now computers on board Soyuz are running the final checklist, and they manage an impressive set of operations, all monitored here from Launch Control. We've got two teams, one responsible for the ground operations, and that's led by the Launch Site Operations Manager, and on the European and Russian sides. And the other team is responsible for the flight readiness of the vehicle, and that's led by the Arianespace production manager. In Baikonur, launch controls in several bunkers underground, about 50 meters from the pad. But here at the Guiana Space Center, it's in a protected building, which is about 1 kilometer from the pad. So these guys are in another room next to launch control. It's called the CVI, a very important team here. They're collecting the telemetry data coming from our vehicle as it flies over. Now you see that white smoke coming out of the launcher? Well, it's perfectly normal. The first 3 stages of Soyuz are powered by liquid oxygen and kerosene. There's Luca Kekio. Here we're looking now at the O3b team. Brian Holtz. And we also have Stuart Saunders, who's there as well. Very big welcome to Stuart. So I was saying the liquid oxygen and kerosene, we have to keep oxygen at extremely low temperatures if we want it to be in a liquid form. Minus 183 degrees to be precise. That's very cold. And so what you can see there, that white smoke, is actually the liquid oxygen evaporating. See that big grey mast? That's called the KZM. It's the upper composite umbilical mast, and inside it are all the umbilical lines which are taking information from the satellites to the teams on the ground. Now those lines are shortly being disconnected. We won't actually be able to see that happening because they're inside the mast, but you will see that KZM mast retracting, or pulling away if you like, literally just before the launch, so that's something to look out for. And the range operations manager has just announced that those lines are now being disconnected. Now below the KZM is another mast, and that's called the VKM. That's the lower stage mast, and we can't really see it because it's underneath the KZM, but that houses the electrical links between the ground and the vehicle. And that's going to retract shortly after the KZM. Quick word about the ignition sequence on Soyuz. There's a system for checking the health of the engines before it leaves the pad. The engines on the 4 boosters and the core stage are all ignited 17 seconds before liftoff, and the thrust is then gradually increased to check that the engines are all working well. Don't forget that Soyuz also carries people into space, so we really have to be absolutely certain. And the engines are then throttled up to full thrust, and at that point, Soyuz leaves the pad. So you can count to 17 seconds when you see the first thrust. A couple of things to watch out for. Minus 35 seconds, that big grey mast pulls away.
Attention pour H0 moins 1 minute.
Minus 18 seconds, the VKM, then minus 17, we ignite the engines.
H0 moins 1 minute.
We are 1 minute to launch. We're orbiting the second 4 satellites in the O3b constellation, which Thales Alenia Space built for O3b Networks. And we are flying on board the 8th Soyuz to launch from its new home here at the Guiana Space Center. 40 seconds, Soyuz is switching to onboard power. Watch out for that big metallic tower being pulled away. There it goes.
Largage ma KZM.
Our very best wishes to the teams.
À tous de DDO, attention pour le début de la séquence d'allumage lanceur. Top H0 moins 20 secondes. Top largage ma VKM. Top allumage triétage. À tous de DDO, attention pour le décompte. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, padium. Décollage, lift-off, c'est parti. paramètres à bord sont normaux. Les moteurs des premiers et deuxième étages fonctionnent normalement.
And there she goes. Soyuz is pulling itself away from the gravitational pull of our planet. We are heading out east over the Atlantic Ocean.
Les paramètres à bord sont normaux.
That's because it's more efficient for getting to our orbit. It saves on propellant. We're travelling in the same direction as the Earth's rotation. It's a little bit like a boat on the river, going with the tide, going with the flow. If you think about it, Soyuz is already travelling in the right direction when it's on the pad, because Earth is moving. We just can't feel it. So, we're burning 5 engines right now, but the boosters, those 4 there, are the ones that are doing all the work. Gravity makes us stick to our planet, but it also makes it incredibly difficult to get away, and that's why we need so much firepower. Take a look at the bottom of the screen. You can see there on the left is our altitude. At the moment we're 29 kilometers above the Earth. He says that everything is nominal, everything is going according to plan. The distance is the distance on the ground. If you were to draw a straight line on the ground from the CSG, and the speed there, we're travelling at 1.71 kilometers per second. So, our boosters have done their job. They're falling away back to Earth. We don't need them anymore, and we are shedding weight because they have burnt all their fuel. Look at those superb pictures. Those are images from the onboard cameras from the previous launch, and those boosters twisting as they are designed to do. He's telling us that everything on board is going according to plan, everything is normal. So we're burning the main core stage. That burns for just under 5 minutes. And a word about the confirmations of the major events in the flight. We're seeing key moments happening at the right time, but we get everything's nominal, but we get the actual confirmations of those milestones slightly later. That's perfectly normal. It takes a little time for the information to get to the range operations manager, and he will call out those confirmations when he gets them. Take a look at the top of the vehicle there, the front of the vehicle, the nose of the vehicle, that rounded section is called the fairing. The fairing is housing our satellites. They're actually inside it, for anybody who's not familiar with how a launch vehicle works. And the fairing is protecting the satellites from the rigours of the launch. You can just imagine how loud it is when the launcher lifts off. Those acoustic vibrations could be dangerous for the satellite if it wasn't protected, and that's what the fairing does. It's all planned to protect and keep our satellites lovely and safe. The other thing is friction. The launcher is flying through the dense part of the atmosphere at very high speed. And we're now out of that dense part of the atmosphere because the fairing is falling away. We don't need it anymore, and these satellites can be exposed to space. And we've had the confirmation there from the range operations manager. So we can see our satellites for the first time, our 4 babies, the O3b spacecraft. You can see those blue rectangles. Those are the solar panels. The satellites are all folded up during the launch, just like butterflies. When they come out and get separated, when we release them into space, they'll be unfolding their wings, just as if they were coming out of a cocoon. Amazing to think that it took us only 4 minutes to get into space. So we're now getting the 3rd stage ignition. Soyuz ignites the 3rd stage before releasing the 2nd stage, and there you can see those superb images again from the onboard cameras. So we're now burning the 3rd stage.
Allumage du 3e étage, extinction du 2e étage et séparation du 2e étage. Séparation de l'interétage.
And we can see we're leaving the coast of South America behind us there, heading out across the Atlantic. There's the tracking station in Galileo. Galileo is the tracking station here at the Guiana Space Center, and you can see where we are there on that image of our
fonctionnement
planet.
du moteur du troisième étage est normal.
These computer-generated images that we're looking at are showing us what experts have calculated is actually happening to the launcher and the satellites. Basically, the teams plan a very precise schedule of events. It's all based on extremely accurate predictions. They put all of that information into a computer, and the images that we can see there on the right-hand side of the screen are a simulation of those predictions. So pretty well every movement, every position you see, every burn, every blast of an engine is based exactly on what has been planned for the flight. And here we're looking at the 4 satellites. Let's just talk you through this. For anyone who's unfamiliar, the round section in the middle is the dispenser or the attachment system. The satellites are attached to that. And then if you go move to the right, you can see that gold tube is the frigate. Today is the 6th launch of the year, and Arianespace is preparing 4 launches at the same time here at the CSG. In April, the light lifter of the Arianespace family, Vega, performed its 3rd successful launch from the CSG when it orbited Kazakhstan's first Earth observation satellite, CasiOSat-1, built by Airbus Defence and Space. At the Berlin Air Show, Arianespace debated the future of the launcher business, highlighting its position as world-leading launch services provider for more than 30 years. And Arianespace showcased its expertise at the 24th Communicasia trade show in Singapore, with information technology professionals from over 100 countries. Arianespace orbits more than 60% of the Asia-Pacific region satellites, with 9 launches planned for customers in Australia, India, Indonesia, Japan and Malaysia. At the CSG, it's busy times. Teams are preparing the next 2 launches. The ATV cargo ship to the International Space Station is now integrated with Ariane for launch on the 24th of July. And standard tests are proceeding on the frigate upper stage to launch the first 2 fully operational satellites in Europe's positioning system, Galileo, in August, with 2 more planned by the end of the year. So let's just continue talking about what we're looking at here for anybody who's unfamiliar with a launch. Let's work from the front backwards. We've got those 4 satellites attached to the dispenser, the adapter system. Then you can see a round structure, a gold structure. That's called frigate. It's the upper stage of the launcher. Then after that you can see the tube, as it were. That is the remaining 3rd stage, with its engine burning away there, powering us out across the Atlantic. The flight path takes us east across the Atlantic and along the equator, and we're tracking the launcher using ground stations. It's called telemetry. We saw the guys receiving information earlier at the CVI. Soyuz sends data to those ground stations as it flies over. And this tells us how the flight is progressing in real time. And the tracking stations, the information from the tracking stations is then downloaded to the CVI. Everything's going according to plan, and you can see the superb curvature of the Earth there. So we've just picked up the signal at the ground station in Brazil. And we're getting there the 3rd stage scheduled separation. There it goes. So we're now beginning the next phase of our journey. This is where frigate takes the wheel. Frigate is that gold structure I was just talking about. It's actually made of 6 spherical tanks. Now there, look at that wonderful image of the previous launch. That was the 3rd stage falling away. The 6 spherical tanks, which are organised in a circle, you can see them there. Getting the confirmation there of the extinction and separation. 4 of those tanks are for propellant and 2 of them are for avionics. Avionics is what you would find in the cockpit of a plane, the flight control systems, navigation, communications, etc. And it's attached using that special dispenser. frigate's getting ready to switch on its engine. It's called the pre-burn phase, and it's giving a quick burst of acceleration to push the fluids back in the tanks to make sure that there's enough propellant to ignite the engine properly. It's a little bit like being pushed back into the seat of your car when you press the accelerator. So we've now ignited our engine. Frigate has switched its engine on for its first burn. It's going to burn for about 4 minutes. Frigate's job is to deliver the satellites to their drop-off point in space, and it's going to take us a couple of hours to get there. During that time, we will have 3 propulsion phases. The first 2 burns take us to what we call the transfer orbit. Then there's a coast phase. That coast phase is going to last for about 1 hour and 17 minutes, the coast phase without the engine. And then frigate will switch its engine back on again for the third burn, which will take us to our separation orbit. And that's where we will release our satellites. Frigate was originally designed as an interplanetary probe and was adapted to fly on board Soyuz, and it can switch its engine on and off up to 20 times. They can take passengers pretty well anywhere they need to go. Soyuz is the medium lifter in the Arianespace family. The other 2 are Ariane 5 and Vega, and it's been a busy year for Arianespace with new contracts being signed.
I had the pleasure and the honor, on behalf of Arianespace, to sign the contract for the launch of BRISAT-1 on the 28th of April with Sofian Bashir, CEO of the Bank Beri of Indonesia, and in presence of His Excellency, the President of Indonesia, various Indonesian ministers, and the French and US ambassadors. This shows the importance of this program for the first bank of Indonesia, its 11,000 local branches, and for Indonesia itself. This is the reason why Arianespace has been chosen. Once again, and as Sofian Bashir explained, the unmatched reliability of Ariane 5, its availability, and the professionalism of Arianespace teams have been key factors for this choice that occurred after a demanding international process. For Arianespace, this program is very important. It's the first time a bank orders a satellite, and we are very proud to have been chosen to launch it. When it comes to ensuring the start of new business, 37 new operators have already chosen Arianespace for their first satellite. It's also the 5th Indonesian satellite to be launched by Arianespace. All previous Indonesian programs have been successfully launched by us. Finally, Arianespace is back in Indonesia after an absence of 9 years, and due to the dynamism of the Indonesian market, I expect some more successes in the months to come.
Incidentally, today is the Russian vehicle Soyuz's 8th launch from its new home here at the CSG. And in that time, it's already orbited 21 satellites. So we've just heard there from the Range Operations Manager that we've picked up the signal now at the tracking station in Ascension Island. Ascension Island's in the middle of the Atlantic. We're just over 13 minutes into the flight there, coming up to 14 minutes. So the upper stage is powering us across the pond towards the west coast of Africa. In the early phase of the launch, we were using all of our power to get away from the Earth. Well, now we're using it to go faster so that we can start climbing higher into space later in the flight. We need to get to just under 800 kilometers to start the process of releasing our satellites. That's actually 7,831 kilometers to be precise. And here we have the scheduled cut-off. First frigate cut-off of its engine, switching its engine off, and we are entering what we call the first ballistic phase. That's going to last us 8.5 minutes. Ballistic actually means without propulsion. So right now, we are travelling high enough and we're travelling fast enough to cruise without our engine. It's very useful for saving propellant, but it's also to optimise the conditions of the flight. Let's turn our attention to our passengers, O3b. It is, as we said earlier, a truly pioneering project, both in its aspirations and its technology, and Arianespace is really pleased to be part of that. The aim of O3b is to provide affordable high-speed internet from space to billions of people who are presently unconnected. And I think it's fair to say that a lot of us in certain countries, we take our internet.
Extinction nominale du moteur frégate.
He's just confirming the switching off of the engine there. We take our high-speed internet for granted, but the truth is it really is a privilege. And now that privilege is going to be extended around the globe and make fast internet more ubiquitous, more accessible. Arianespace is really delighted, as I said, to be playing its role in helping to reduce that digital divide, having launched 4 satellites so far and another 4 next year. 4 launched last year, 2 on the way, and 4 next year. So once these 4 are deployed, O3b will be fully operational.
So the idea for this launch is about vision to reality. We started life with the idea that people should be connected, that the internet is the most transformative technology of our generation and that everyone should have the opportunity to participate. This launch really marks the full launch of O3b service, and we're really excited about what our customers are going to be able to do with that.
Gee, what I've seen of O3b so far just blows me away. And it works, it really does work. O3b claimed this would be fibre from the sky, and it absolutely is.
All of a sudden, the whole situation changed, and we could see, you know, I used to speak with a number of those people who were fairly critical about our service, and then they just came to me with a huge smile on their faces and saying, "Wow, this is Timor Telecom's internet is way better now. What did you do?"
As a matter of fact, I had the privilege of trying this technology, and the experience was absolutely mind-boggling. Knowing what we had before and what we finally have now, it was literally day and night. And I couldn't be more thrilled for our customers that we now finally have the type of technology which is comparable to what they have in the Western world.
We've been fantastically excited by what we've seen in the performance of the satellites to date, and more importantly, our customers have been excited. They've been demanding that we get into commercial service, and as a result, we're already delivering 155 megabits per second into the Cook Islands. We're starting to bring up customers in East Timor with Timor Telecom, in Kinshasa with Raga, in Samoa with Digicel. We're really now at the stage where we're launching full commercial service.
For now, we are connected on O3b, and we are doing this conversation over the Skype, and you can see that it is reliable in terms of quality. There is no drops, there is no latency, and it's very clear. Indeed, O3b is impacting almost 3 months right now. Connection with them, we are very happy, and there is nothing to compare with any other providers.
We are not only able to bring voice to them, we'll be able to bring broadband services where they are able to surf YouTube, social networking. This will literally change their life.
So another great example of what we've seen so far is with Royal Caribbean. So with Royal Caribbean, we've got a very, very unique solution. We've got the largest cruise ships in the world going to be connected with O3b, and the first one, the Oasis of the Seas, we're now on board. We have full sea trials operating. We're delivering more than 500 megabits per second to the ship.
We have to face the fact that everybody wants to stay connected. It's not necessarily something that is a nice to have, it's a must have for people today. And this relationship and this launch that we're having with O3b today enables us to bring that level of connectivity to everybody on the ship and to provide the same level of experience that they would provide from their home today. It's a game changer for us, and it's a game changer also for the guests that we're going to attract to come on board.
I think there's enormous opportunities. I think as people's data needs continue to increase, there's going to be need for more and more high-speed, low-latency technology. So I think it's extremely important for the future of the DRC.
We already stepped into the future now. O3b is not only moving our business, it is also moving Samoa market and other markets into an innovative world. It is the most reliable technology that will push the data services into the next era.
So I don't ever see this stopping. I never see a day where we're not going to be able to launch satellites and deliver the kind of services that we're doing. We've just hit the tip of the iceberg in some of the largest countries of the world where connectivity and internet penetration levels are still very, very low.
And connectivity is always the first highway that brings people and communities to life. As time passes, we will be addressing areas like health, telemedicine, education, e-learning, e-governance, public safety, and other data services and voice services that would be required in those parts of Pakistan where there is no connectivity.
It's just going to open up possibilities that weren't there before. It's going to make us more viable as a country. It's just going to be a transformation for the whole community.
Some interesting thoughts there about bringing telemedicine, e-learning, health to communities, very important things. Telemedicine is medicine from a distance because, of course, tele means distance. There's Steve Collar there, who we saw in that film. And beside him, Jean-Louis Gall from Thales Alenia Space, who built these wonderful satellites. Congratulations to everybody for such a feat on that. So yes, tele means from a distance. Telemedicine, medicine from a distance. Television, vision from a distance. Now, we have had acquisition at the tracking station in Libreville during that film. That's in Gabon. It's picked up the signal and we're flying over the west coast of Africa. We've crossed the Atlantic in, well, under 22 minutes. Quite something. That would take us 6 hours in a jumbo at least. And we've got those superb images there in our simulated images of the Earth and our launcher flying out with our satellites. So frigate's entering the pre-burn phase. It's preparing to ignite its engine. That takes it 55 seconds. It gives a short burst of acceleration using small thrusters from the attitude control system, and this pushes the fluids back to the bottom of the tanks. As I was saying earlier, it's just a little bit like when you accelerate in the car, you get pinned back against the seat.
Deuxième allumage frégate du moteur frégate principal confirmé. Les paramètres à bord sont normaux.
Okay, so we have the ignition of the engine and everything's going fine, he says. To connect all these people, going back to O3b now, they really had to think outside the box, and they came up with a very clever idea. They decided to put the satellites closer to Earth at 8,600 kilometres instead of the usual 36,000 kilometres, and that was to eliminate the delay, the latency as it's called, as we all know. When we see reporters on the TV talking to effectively satellites that are 36,000 kilometres above the Earth, it always takes a few seconds. There we go, some people there in the room. A few seconds for the signal to come back down to us. So as I was saying earlier, another long-time partner of O3b is Thales Alenia Space, who designed the satellites and built the satellites. In fact, they agreed to be part of this project right from the start, as did Arianespace. Let's go over now to their CEO, Jean-Louis Gall, to hear from him.
O3b is a pioneering and ambitious project. It's really at the vanguard of providing high-speed solutions for space with shorter delays, and we at Thales Alenia Space are extremely pleased that the second batch of O3b satellites is now on its way. The first 4 satellites have been orbiting for 1 year, and they are offering extremely successful services, confirming the high throughput and low latency of the O3b promise. We are very proud to be part of this endeavor and its unprecedented operational and beam flexibility, its potential to connect billions of people who have had so far limited access to broadband. It's a real honor for Thales Alenia Space to be O3b's prime industrial partner and to be able to support this exciting new company right from its conception. I would like to underline the outstanding partnership between the teams at Thales Alenia Space and O3b and the high quality of exchanges we always had with our customer. Today is a major event for O3b since it marks the second step of implementation of the constellation. And right now, we are integrating and testing the third batch of satellites ready for launch in early 2015. We are fully committed to support O3b to make this constellation a great, great success. Our congratulations to Arianespace and to all the teams involved in the project for the fantastic job they have done. Our warmest thanks also to O3b for their trust. You can count on us.
So here we are, heading out across Africa. We've had acquisition, or getting acquisition of signal from Malindi. That's the tracking station picking up the signal over there on the east coast of Africa. Look down at the bottom, you can see that our altitude is 174 kilometers above the Earth, and we're traveling at 7.88 kilometers per second. I'm going to say that again, per second. That's incredibly fast. And on the top right-hand side, you can see the curve there, our trajectory of our flight. We've plateaued out. We're going to start climbing now. I mentioned earlier that Thales Alenia Space is very experienced at building telecoms constellations. In fact, they are the prime contractor for two other constellations, apart from O3b, Global Star and Iridium. If you add them all together, they've been working on 117 satellites of about the same size and weight, so that's quite impressive. That's a lot of satellites to build. O3b clearly in very good hands here. Frigate, upper stage, powering us out. Now we're starting to climb. Starting to climb higher and higher into space. Andreas Dulvaris is the satellite mission director for the O3b satellites. He's been working closely with Arianespace and Thales Alenia Space.
First, I'd like to express how excited we are to be back here at the Guiana Space Center since our first launch over a year ago. Regarding our relationship with Arianespace, we have an excellent partnership, which is very important to a successful launch campaign. Planning and coordinating the logistics required to start and then execute the launch campaign is a very difficult process, and without this partnership, we would not be successful. As we are faced with many tough decisions throughout the campaign, for example, the selection of the launch date, working weekends and or holidays to maintain the schedule, I appreciate the full transparency from Arianespace and the willingness to compromise for the good of the program. As there are occasions when we may not share the assessment with Arianespace, Arianespace has always been professional and respectful to our needs. It is with this spirit that we operate and are able to achieve a successful launch campaign. I would like to say a special thank you to Luca Cecchio, who is currently the Arianespace O3b program director, for all his hard work and dedication on O3b as he moves into a new role within Arianespace. Without Luca's hard work, we would not be as successful as we have been, and we will miss him. We look forward to working with Arianespace on our next launch campaign later this year or early 2015.
So we've left the east coast of Africa behind us. There's Andreas there. We're flying out across the Indian Ocean towards Southeast Asia. We're crossing over the beautiful islands of the Seychelles, the Maldives, flying out across Indonesia. We'll be heading out across Papua New Guinea, and then we'll head out across the Pacific Ocean back towards the northwest coast. Everything's normal. Head towards the northwest coast of South America. In fact, we will have done a full lap of the Earth in a couple of hours. Not bad. And you can see the sun rising there over the curvature of the Earth. Pretty impressive. Frigate will shortly shut its engine down for 1 hour and 17 minutes. And it will then reignite its engine to get to the separation point. During this time, it's going to go into a barbecue phase, we call it. It does what it says on the tin. It rotates as if it's on a spit, and that ensures homogeneity of the thermal conditions around the satellites. It basically keeps everything the same temperature. And Frigate's getting ready to switch off its engine. It's reducing its thrust slowly. Its engines prefer to run down the remaining fuel at reduced power because it's steadier. So now we have the scheduled engine shut down. Frigate is entering. Frigate's entering its next ballistic phase, its coast phase. It's going to coast without its engine for just over 1 hour and 17 minutes. And we're going to lose telemetry during that time. That means that we will be losing visibility of the launcher. We had the confirmation there that Frigate has switched off its engine now. We'll be losing telemetry for about 44 minutes during that time. We lose visibility, we call it, of the launcher, even though we're not actually seeing it, we're sensing it. So it means that it'll go out of range of the tracking stations for that time, and then we'll pick up the signal again at the ground station at South Point in Hawaii, where Frigate will check in. And then after that, Frigate will switch its engine back on, ready for the next phase. You could see that superb curvature of our planet there. Well, we launched 32 minutes ago. Superb launch there into the blue skies over French Guiana, Kourou. Pretty spectacular for those who went outside to watch it from the viewing station here at the Guiana Space Center.
La phase balistique qui suit la deuxième extinction frégate va durer un peu plus de 80 minutes.
It was a perfect launch. Everything went absolutely smoothly and according to plan. We're going to be coming back to you shortly. We'll take a break now because, as I said, Frigate has shut its engines down. It's going to be going...
Fin de visibilité attendue du lanceur par la station de Malindi. Le lanceur restera en absence de visibilité de toute station pendant environ 45 minutes avant d'être récupéré par la station de South Point sur les îles Hawaï.
There you go. He's just announced that the... Hello everybody, welcome back. I'm Katie Haswell. We are coming to you live from the Guiana Space Center. Right now, the second batch of O3b satellites are hurtling through space on board the frigate upper stage, about to enter the next phase of their journey. We lifted off from the pad at the Guiana Space Center on board Soyuz 1 hour and 51 minutes ago. And it was a textbook launch. Everything went according to plan, like clockwork. We lost the boosters after a couple of minutes, and then the fairing 2 minutes later. And the rest of Soyuz then fell away. And we're now left with the frigate upper stage. Frigate's job is to deliver our satellites to their injection point. And that's where it's going to release them so that they can continue on their own for another couple of 100 kilometers to their final orbit. Frigate's getting ready to switch its engine back on so it can put the satellites into the right position for their journey. And there we can see a replay of that launch earlier today. Superb launch there. We actually got some nice blue skies. And as I said, Frigate's getting ready to switch its engine back on. Okay, so here are the teams. And as I was saying earlier, Frigate's going to switch its engine back on shortly so that it can put the satellites into the right position for their journey. We have a little under 5 minutes left on this burn. It's switched its engine on. We're flying across the Pacific Ocean along the equator, and we're heading towards the northwestern tip of South America, towards the coast of Ecuador and Colombia. So, we're very lucky to have with us here in the commentary box Steve Collar. Steve is the CEO of O3b Networks. And Steve, you were with us earlier. Everybody saw you there when you were chatting with me in the interview and also in the film. Steve, in many countries, we take our high-speed internet for granted. That's not the case for a lot of people. O3b is going to be supplying some very important services to parts of the world where right now they can't get internet, or at least fast internet that we're used to. How's it working? How does it actually work?
Well, so one of the most gratifying things since having the first 4 satellites up in orbit is that we've been able to deploy services, and we've been able to talk to our customers, and they've been able to get a reaction from their end users. And so what we're doing is we've brought the satellites much, much closer to the Earth. They're 4 times closer to the Earth than traditional geostationary satellites. And that's the only way you can overcome this problem, this Achilles heel of satellites, which is latency. So it's a long, long way out to geostationary orbit. It's 36,000 kilometers. And there's no way to sort of reduce the amount of latency, the amount of delay that you get. You're familiar with television transmissions when you're over the satellite link and you get this extraordinary delay. That's just the signals going out to geostationary orbit and coming back again. So our satellites being that much closer to the Earth, we don't get that delay. We've more or less eliminated that effect. The latencies with our communications are equivalent to or less than terrestrial communications, which means we really can deliver the same quality of service as can be delivered through fiber or through microwave.
It kind of begs the question. I wonder why nobody thought about it before.
Well, they did, but it makes the networks a little bit more complicated, a little bit more challenging. But these are problems that we've solved. These are challenges that we've solved, and really there is no other choice. When you understand, and this was very much Greg Weiler's passion, our founder, but it's absolutely borne out to be true. When you're convinced that latency is going to cause significant problems in networks going forward, then there's no other choice. The compromise is just too great to be deploying services from geostationary. You have to bring the satellites closer to the Earth. And once you've decided that that's the way you're going to design your system, then it becomes relatively straightforward, and then it becomes an integral part of the design. And up until now, we've always thought about latency as only giving us problems with voice connections, with video connections. But actually, with data, with IP, latency is even worse, because when networks see latency, they think they're seeing congestion, and they start to react in exactly the same way as they do in congested networks. They stop sending information, and as a result, everything slows down, and the performance slows down, and all of those applications that you're reliant on, that a business in Kinshasa, for example, is reliant on, stop working. So whether that be CRM applications for running businesses, whether that be booking travel. We've all had an experience of getting 3/4 of the way through a travel booking and the whole thing shuts down. Well, this happens as a result of 2 things, either congestion or latency. One of the most compelling interviews we made of an end user of Telecom Cook Islands was with the CEO of the airline in Rarotonga in the Cook Islands. And airlines are fundamentally reliant on being able to connect with other airlines in order for the booking systems to work. And he was basically saying that with O3b, his business has been completely transformed. It's been completely revolutionized. And those are the sorts of stories we love to hear.
And you know, I think also, as we were saying earlier, people are just so used to having that sort of instant thing now. It's very difficult for us to even contemplate a fraction of a second's delay. So, I mean, just to explain for people who are unfamiliar with the term latency, just to repeat again, it's that delay that we get when a signal bounces up to a satellite and back down. But before we go on, Steve, I just want to quickly point out to everybody that we've switched our engine back on again. Frigate's back up and running, switched its engine on to start heading now to the position where we can start orientating our satellites. And if you look at the top right-hand side of the screen back there, you saw the curve there, and it's switched it off briefly again. So, Steve, going back to the whole sort of subject of latency and speed, your first 4 satellites are actually operating? Presumably that means.
No, they absolutely are. They absolutely are. So we're live and in service in the Cook Islands, in Papua New Guinea, in East Timor, in Kinshasa, in Samoa, and so with 4 satellites we can provide pretty much the same service that we can provide with 8 satellites, but just in fewer places. With what 8 satellites does for us is it allows us to deploy globally. We can now light up customers worldwide, and 12 satellites we can bring even more capacity. But yeah, no, we've been able to fully check out the service with 4. And the customers who are up and operational in live service, we were having dinner with the CTO at Timor Telecom, who was explaining to us that he was actually getting calls from his customers asking what he'd done to his network that improved services so dramatically. He was, you know, that his customers couldn't quite believe that there'd been this dramatic improvement in their service. These stories, as I say, are exactly what convinces us that what we're doing is exactly right. That we're on the money with the constellation that we have, and excited to keep rolling out services.
Yeah, I can see that, and it's very important. And what we're talking about here as well is bringing services from space rather than cables along the ground. I tell you what, we're getting close to the first separation, so why don't you nip downstairs? Steve's going to hop downstairs and watch that from the room, and he'll come back again to join us after the first separation of the first 2 satellites, because of course we are separating our satellites 2 by 2. Just to remind everybody what we're looking at here, we can see the frigate upper stage. It's that gold structure with the spherical sections on there containing propellant and avionics. Right now it's twisting very slowly. Well, it looks like it's twisting slowly, but to us, but of course things happen in space at different speeds to how we perceive them. And we are actually travelling here at a speed of 4.26 kilometers per second. We're at an altitude of 7,837 kilometers, and we are at a distance of 12,500 kilometers from our launch pad. If you were to draw a line across the Earth, actually on the ground, a straight line. Right now, we are going through a complicated set of orientation maneuvers. Frigate has to position our satellites in a very precise attitude so that they can separate and then travel on their own journey into space. It's all very carefully planned. And to do that, it performs these orientation maneuvers. This is the scheduled separation here of our satellites, the first 2 satellites. And you can see them there moving away from the dispenser, which has been attaching them to the frigate upper stage. So congratulations to O3b for the release of their first 2 satellites, but we still have 2 more satellites attached, and we're going to wait another 20 minutes or so before those can be released. frigate will need to go through another set of orientation procedures in order to be able to...
Séparation des satellites O3b 2 et 4 confirmée.
So we have confirmation there of the separation of the first two satellites.
Début des manœuvres d'orientation au profit du 4e booster frégate.
The first two satellites, satellites 2 and 4, and we're now at the beginning of the next phase of the maneuvers as the range operations manager called out there. The range is the word that we use, which describes the entire spaceport here at the Guiana Space Center, but it also includes the downrange stations. That's a lot of people. You can just imagine the logistics of all the different people who have to listen in and get the information. And the range operations manager is the person who really collates all that information and calls it out so that everybody across the planet and in those telemetry stations all along the equator can hear what he's saying. We can see we've got our other two satellites there attached to the special dispenser frigate performing the next orientation movers. Frigate is a very clever piece of kit. As I mentioned in the first phase, it can switch its engine on and off. O3b Networks has been operating for about 7 years now, and in that time they've grown.
So the idea for this launch is about vision to reality. We started life with the idea that people should be connected, that the internet is the most transformative technology of our generation and that everyone should have the opportunity to participate. This launch really marks the full launch of O3b service, and we're really excited about what our customers are going to be able to do with that.
See, what I've seen of O3b so far just blows me away. And it works, it really does work. O3b claimed this would be fibre from the sky, and it absolutely is.
All of a sudden, the whole situation changed, and we could see, you know, I used to speak with a number of people, of those people who were fairly critical about our service, and then they just came to me with a huge smile on their faces and saying, "Wow, this is Timor Telecom's internet is way better now. What did you do?"
As a matter of fact, I had the privilege of trying this technology, and the experience was absolutely mind-boggling. Knowing what we had before and what we finally have now, it was literally day and night. And I couldn't be more thrilled for our customers that we now finally have the type of technology which is comparable to what they have in the Western world.
We've been fantastically excited by what we've seen in the performance of the satellites to date, and more importantly, our customers have been excited. They've been demanding that we get into commercial service, and as a result, we're already delivering 155 megabits per second into the Cook Islands. We're starting to bring up customers in East Timor with Timor Telecom, in Kinshasa with Raga, in Samoa with Digicel. We're really now at the stage where we're launching full commercial service.
For now, we are connected on O3b, and we are doing this conversation over the Skype, and you can see that it is reliable in terms of quality. There is no drops, there is no latency, and it's very clear. Indeed, O3b is impacting almost 3 months right now. Connection with them, we are very happy, and there is nothing to compare with any other providers.
We are not only able to bring voice to them, we'll be able to bring broadband services where they are able to surf YouTube, social networking. This will literally change their life.
So another great example of what we've seen so far is with Royal Caribbean. So with Royal Caribbean, we've got a very, very unique solution. We've got the largest cruise ships in the world going to be connected with O3b, and the first one, the Oasis of the Seas, we're now on board. We have full sea trials operating. We're delivering more than 500 megabits per second to the ship.
We have to face the fact that everybody wants to stay connected. It's not necessarily something that is a nice to have, it's a must have for people today. And this relationship and this launch that we're having with O3b today enables us to bring that level of connectivity to everybody on the ship and to provide the same level of experience that they would provide from their home today. It's a game changer for us, and it's a game changer also for the guests that we're going to attract to come on board.
I think there's enormous opportunities. I think as people's data needs continue to increase, there's going to be need for more and more high-speed, low-latency technology. So I think it's extremely important for the future of the DRC.
We already stepped into the future now. O3b is not only moving our business, it is also moving Samoa market and other markets into an innovative world. It is the most reliable technology that will push the data services into the next era.
So I don't ever see this stopping. I never see a day where we're not going to be able to launch satellites and deliver the kind of services that we're doing. We've just hit the tip of the iceberg in some of the largest countries of the world where connectivity and internet penetration levels are still very, very low.
And connectivity is always the first highway that brings people and communities to life. As time passes, we will be addressing areas like health, telemedicine, education, e-learning, e-governance, public safety, and other data services and voice services that would be required in those parts of Pakistan where there is no connectivity.
It's just going to open up possibilities that weren't there before. It's going to make us more viable as a country. It's just going to be a transformation for the whole community.
And there's Frigate. During that film, we started another barbecue mode. You can see it twisting around there as if it's on a spit. It's keeping those temperatures nice and even all the way round because the sun is extremely hot in space. Steve, you're back with us up here now. You've got your first two satellites separated. What does that actually mean?
Well, for us, you know, everyone is excited by the launch because it's such a visual demonstration of everything that we're trying to achieve. But it's really separation where we feel more and more secure that the satellites are now out on their own. We can start commanding them. We can start bringing up their systems. We can start deploying the arrays and bringing them under control. So having two deployed, knowing that we have two out there, we're already, you know, we'll be looking for them coming over the horizon, bringing up the TT&C, so the command system for the satellites. We just need the next two to be deployed and to be separated. And then actually a lot of hard work starts for our engineering team, because now it's the time where, as I say, we start moving the satellites into position. They're not yet, when they get dropped off by Arianespace, they're not where we need them to be. So we then need to start firing the engines on board the satellites, moving them into position, putting them into our constellation, and then starting to test them, make sure that everything is checking out properly before we actually put them in the constellation and start delivering services to our customers.
So they've got to climb a bit further, haven't they?
They've got to climb a bit further.
Yeah.
They've got to climb a bit further, and we've got to position them within the constellation. So if you imagine, you know, a clock face, so we're putting satellites at kind of 12, 6, 9, and 3, and then the intermediate spaces in between. So we have to make sure that we complete the orbital ballet, as it were, with the 8 satellites that we have.
How long is it going to take them to get there?
So it's about a week to 10 days before we're in a position to then start our in-orbit test phase. And that means that we're able to start turning on transponders and putting down signals to the Earth and making sure that the satellites are all checking out. So, but there's a critical phase over the next, couple of days where we're deploying the arrays, we're checking out kind of the bus subsystem, the main spacecraft subsystems. before we then get into the payload testing.
And the bus being the sort of the platform.
Yeah, the platform,
which it's built
exactly.
on.
So the platform's there to make sure that the satellite is pointing in the right direction, that it's got enough power, that it's thermally controlled, and the payload is. I'm a payload guy, so I'm going to tell you that the payload is the important piece. So this is the piece that we really care about. This is the thing that's carrying the communications up to the satellite and back down again.
So Thales Alenia Space is in charge of flying the satellites during the very early phase. It's called LEOPS, Launch and Early Operations.
As the launch campaign ends, the birth of the next 4 satellites begins at the separation point. Once the satellites are separated from the upper stage of the frigate, the satellites are then acquired by the ground team in Cannes, which is comprised of Thales and O3b. At this point, the satellites go into what we call a safe pointing mode, such that they are pointing towards the sun. The team in Cannes, the LEOP team, will then transfer the satellites from the safe mode position into an Earth pointing position, which is the normal operating orientation. After we have completed the orbit raising to the mission altitude, we will then perform the payload in orbit testing. This should take about 20 days to fully characterize the payload. Once this has been completed, the satellites will then be ready to be put into full service with the previous launched satellites.
Andreas there, giving us the lowdown on the LEOPS phase. He's been working with the guys and girls at Thales Alenia Space who built the satellites, and they've, I think, can be quite rightly proud of themselves. It's been a lot of innovation on these spacecraft, and they're very experienced in building constellations.
Yeah, no question, and our success fundamentally depends on the success of Thales Alenia Space and of Arianespace, and vice versa. We're kind of locked in this partnership, which has been incredibly strong between the three of us. I think you heard Stefan and Jean-Louis speaking about the relationship between the teams, and it's not that typical, to be perfectly honest with you. It's something fairly unique that we've managed to sort of grow, and I think it's partly because of who O3b is and the way that we're a startup. We're doing something new, we're doing something different, and so we get this. We bind people together with this story that we have.
And it takes a lot of guts to get involved with people at the beginning, in the early stages, the inception of a business, when you never quite know how things are going to work out. So obviously people had true confidence in O3b, and of course the Thales Alenia Space and Arianespace being committed at the beginning as well is something that would have presumably lent support to O3b as it's developed.
No question. I mean, when you are starting a business, whatever the business is, you rely on, and particularly when it's a visionary business, it's a business where you're trying to do something very different. You rely on people getting it, people understanding what you're trying to do, believing in it, and investing in it. Whether that means investing in it financially, whether that means investing time, whether that means investing in your company's resources, and Thales Alenia Space and Arianespace got O3b very, very early. A lot of the credit for that goes to Greg Weiler, our founder, but it also goes to the guys and girls within Thales Alenia Space and Arianespace who really understood what the potential was, and now we will be building and launching our next 4, completing the build and launching them at the end of the year, and then we're thinking about the future. We're thinking about more satellites. We're thinking about how we can really scale this business, and our partnership with Thales Alenia Space and Arianespace, I'm sure, will come to the fore again.
We were talking about the position of the satellites, and that is something that's quite interesting, of course, because you get the satellites closer to the Earth, and it means that the signal, when it goes up and bounces back down again, is almost immediate. But am I right in saying that there are technological issues with that? Because, of course, we have to, if the satellites are in the Van Allen belts, then Thales Alenia Space has been innovative in bringing in new technologies there.
You've got to rethink the whole network. So you've got to design the network to be at the orbit that you want it to be in, and each orbit is unique. Our orbit has some fantastically good characteristics. One of them is that it's a very, very stable orbit. So we don't actually have to command our satellites. Most satellites, certainly in geostationary, you're having to send commands to fire thrusters on board. You know, typically every week or so. We can go weeks and weeks and weeks without worrying about our satellites because the orbit is so stable. And even though we only have a very small amount of fuel on board, our satellites will last about 150 years in terms of the amount of fuel that we have to maneuver them. And sure, yeah, you need to take into account, you know, radiation in whichever orbit that you're in. The fantastic thing, again, about having the satellites up there is now we've got real experience. We've got real experience of what our orbit's like, and we're delivering performance that's significantly higher than we expected, and we're seeing impacts from the environment which is meaningfully lower than expected. So we've got kind of that perfect situation of being able to over deliver to our customers and having sort of an extended lifetime and an extended profile for the satellite networks.
You're really trailblazing, aren't you? It must be an exciting place to be.
It is. No, it's great fun, and it goes through the team. We've got a pretty small team, but we've got the best team in the satellite industry. I can say that without fear of contradiction. The team at O3b are a great bunch, and again, it is born out of what we're trying to do. There's a collective will to make this happen.
Let's talk a little bit about the services. What does it actually mean for people on the ground? Who...
Le 4e boost frégate, donc qui consistait en un allumage de 16 secondes de système de contrôle d'attitude, s'est déroulé nominalement.
He was just saying that the fourth boost, frigate's fourth boost...
est maintenant sur l'orbite finale visée pour la séparation des satellites O3b 1 et 3.
Frigate's fourth boost, which was just a quickie, only a few seconds long, was just an orientation boost. All went normally, and frigate's now in the next phase of its orientation manoeuvres. Just a quick word about that curve on the top right-hand side of the screen. You can see how we were climbing in altitude there, and now we've plateaued off because we're on orbit. A bit of debate out there about whether we say in orbit or on orbit.
So you just saw Max Smith there on screen. He's from Royal Caribbean. Royal, again, if you think about being committed early, Royal very, very early got the impact that O3b would have on their networks and on their systems, and we've worked in a great partnership with Royal Caribbean for the last couple of years, and it's so exciting to be seeing our services now being deployed on largest cruise ships in the world, and having those cruise ships, you know, designed now in order to be able to in order to make use of the kind of low latency and high throughput, high bandwidth that we can deliver.
You were talking about the future, Steve. How does it look?
So the immediate future looks like hard work, but that's something that we've been used to. And what I mean by that is for the next 6 months, we're going to be putting more than 30 customers up on the satellite network. So when I say when we go from 4 satellites to 8 satellites, now we really are global, and that means that all of the customers that we've signed and all that we expect to sign, we're going to be putting up in service. But in parallel with that, we're also going to be thinking about what the next generation of O3b satellites are going to look like, what O3b 2.0 will look like, if you like. And there really we have some very interesting things that we're already thinking about, some very interesting things that we know we have the potential of doing from the orbit that we're in. So yeah, the future is very exciting.
Oh, well, I'm really pleased to hear that. Steve, thank you so much for joining us. I'm going to send you downstairs now to watch the next phase as we get close now to the separation of our next 2 satellites. And there goes Steve out of the door of the commentary box here, heading downstairs to watch with his colleagues. So we're picking up the signal from the tracking station in Hawaii. That's the station which is watching the separation. We often call this phase the space ballet because the satellite is dancing. The frigate upper stage is dancing in the sky above us, preparing to release our satellites. Twisting and turning. Every movement that you see there is exactly what's happening in space. I'll just remind you that the teams make a very carefully planned set of predictions which they put into the computer, and these synthesized images are a result of that. So what we're looking at is exactly what has been planned to be happening in space. Arianespace can launch lots of different satellites, all types of satellites actually, to all types of orbits. That's because we've got our 3 launchers here at the Guiana Space Center. Ariane 5 is the big one. That carries the heavy stuff. It's going to be launching the 20-ton ATV cargo ship to the International Space Station in 2 weeks' time. Soyuz, the medium lifter, launching clusters like today, and also Earth observation satellites. And then we have Vega, the light lifter in the family. Recently launched an 830-kilogram observation satellite into Sun synchronized orbit. Two minutes and 22 seconds into the flight. Everything looks like it's happening terribly slowly up there, but the reality is it's happening very quickly. You can see at the moment we're traveling at 4.26 kilometers per second. At one stage we were traveling at over 7 kilometers per second. We're nearly 1,000 kilometers from the CSG, from the launch pad, and we are at an altitude of 7,836 kilometers. Getting close now to our separation time. Satellites are remarkably complex pieces of kit. Once they're in space, you can't go and fix them, so they're designed to last for many, many years. As Steve was saying, they're incredibly robust, and they go through the most remarkable testing procedures. Every tiny component has to be tested and checked, as does the whole satellite. It does mean that the testing procedures for space are probably more rigorous than any other industry, actually.
Et confirmation de la séparation des deux derniers satellites O3b.
And we have confirmation that the second 2 satellites in the O3b constellation are heading out. Massive congratulations to everybody at O3b. Well, I think that feels very good. It was a perfect launch, a superb launch. There we can see the 2 satellites, number 1 and 3 actually. Numbers 3 and 4 separated first, and numbers 1 and 3 separated about 20 minutes later. Congratulations to everybody. I think everyone deserves a very big slap on the back. A job well done. Some smiling and happy faces there. There we go. The end for some people who have been working on this launch campaign now for many, many years, and the beginning for others who are taking on the job of flying the satellites. Here we were, a couple of hours ago, launching from the pad here, the Soyuz launch complex at the Guiana Space Center. It was a textbook launch, a perfect launch. Soyuz heading out into the blue skies above us. We were very lucky because actually it's been raining over the last few days. So it was quite nice to see a bit of blue sky for a change. Brian saying hello to his mum. I'm sure she's a very, very proud mother. Waiting now for the various people to come and talk to us. Another replay of our superb launch vehicle blasting off there into the Guyanese sky on the northeastern tip of South America, on the equator, in the Amazon rainforest. Messages home. I think some very proud husbands and wives and partners and children watching members of their family performing these very precise operations, having worked so hard for today. Waiting now for Stéphane Israël, who is about to take the floor, the CEO of Arianespace.
Mesdames et messieurs, ladies and gentlemen, distinguished guests. So I've just got the confirmation that all 4 O3b satellites had been separated on their targeted medium Earth orbits. Tonight's launch is the second performed by Arianespace for O3b, a little more than 1 year after the first successful flight that marked O3b's debut. With this second launch, Arianespace has thus completed the second major step for O3b in its journey to the land of innovation. O3b Networks is one of more than 40 new satellite operators which have trusted Arianespace to start their business. Behind that choice, there is a true recognition of the reliability and availability of our launch systems. Therefore, I want to express my deep gratitude to John Dick, Chairman of the Board, and to Steve Collard, Chief Executive Officer, for deciding to continue their journey with Arianespace. John and Steve are honoring us with their presence tonight. This is, for me, an opportunity to reaffirm that we will do our best to go on delivering tailor-made launch solutions to meet O3b's specific requirements. This applies to any field of our launch service, whether technical, with customized mission design, or financial, with the implementation of export credit solutions through COFAS, which I deeply thank for its support to our activities. We have also tonight, I'm just looking where he is, but I've found him, Mr. Roman Bosch with us in the CSG. Roman, as everybody knows, is a former CEO and chairman of SES. SES is a majority shareholder of O3b, and we are really happy to have Roman with us after the successful launch we delivered for SES with Astra 5B in March, on the 22nd of March. So thanks, Roman, to be with us. Thank you very much. Following this new success, I would also like to congratulate Thales Alenia Space, O3b satellites manufacturer, represented tonight by Jean-Loïc Gall. The last satellite to be separated tonight is the 135th one built in TAS facilities and launched by Arianespace. Sometimes figures speak louder than words. Arianespace TAS O3b partnership is not just about business. It is about belonging to a community that shares common values. Thanks to the visionary project of its founder, Greg Weiler, and I'm sure that Greg is looking at the show now. Hello, Greg. So thanks to this project, which is to reduce the digital divide by providing high-speed, low-latency internet services in areas of the world where such capability barely exists or are totally absent. This is where Arianespace and O3b come together in this common will to bring the unique capabilities of space down to Earth. Ladies and gentlemen, we have just attended the 8th success of Soyuz from the Guiana Space Center. Soyuz remains the reference for satellite constellation deployment, today with O3b, and soon this summer with Galileo. It should be on August the 21st, European Commission's flagship space program for navigation. I thus want to thank deeply our Russian partners for such a fruitful cooperation, starting by the Russian Federal Space Agency, Roscosmos. Congratulations also to TSKB Progress, who provides the 3-stage vehicle and ST fairing, and to NPO Lavochkin, designer and manufacturer of the frigate upper stage, for another flawless mission. Let me also congratulate the European teams who, alongside our Russian partners, have contributed to tonight's success. Our contractors here in French Guiana, who all play a key role in implementing our launch operations, the CNES team for their efficient and unwavering operational support, and of course, Arianespace teams. As a matter of fact, and until tonight's success, there were 4 launch campaigns conducted in parallel in the Guiana Space Center, 2 on Ariane 5 and 2 on Soyuz. The capability of all teams to organize themselves for implementing such a smooth operational flow on site is impressive. I want to pay a tribute to all women and men who made this success possible. Tonight, with this 5th launch of the year, Arianespace has taken another important step towards its operational objective for 2014. 12 launches from the Guiana Space Center, which is definitely the best spaceport in the world, thanks to the dedication of its teams. Oui, je tiens à le dire en français. Merci à tous les salariés de la base et merci
in French. Thank you to all the staff on this basis, and thanks to all of you for this exceptional success.
Trusting Arianespace with this launch. And before giving the floor to Steve, let me wish a long and prosperous life to O3b and to our partnership. So, Steve, the floor is yours.
Thank you very much, Stefan. Wow, it's a long time to wait for good news, that is, a long time, but we've also not only confirmed that the satellites were dropped off where they were supposed to, but they've actually been picked up where they were supposed to. We've now acquired all 4 satellites, so that's fantastic news. Look, yeah, let's have a clap for that. Let's have a clap for that. Yeah. So, thank you, Mickey. Look, this launch was a really important launch for O3b. We've said it. It's the launch that really completes our initial constellation and allows us to roll out global service. Stefan was very eloquent there in thanking all of the people involved in the launch, all of the people involved in the manufacturing of the satellites. From the O3b standpoint, it's also all of our investors, our shareholders, everyone that's believed in this project and this mission. But in particular, I would say to Thales Alenia Space, to Jean-Louis, and to Arianespace, to Stefan, the relationship that we have is a unique one. It's one of partnership, it's one of cooperation, it's one of openness, and it's one of friendship. So I want to thank you both personally for that, and I want to thank your teams for that. To the magnificent team at O3b, some of whom are represented here, many, many more are represented at our places around the world. Without doubt, the hardest working team in the satellite industry, without doubt, the best looking team in the satellite industry. Hell, I'd say the best looking team in any industry, quite honest with you, but I just want to, you know, it's a genuine privilege for me to go to work with these guys. They are truly, truly inspirational. They are a great bunch. So, as important as this launch was for us, it was also super important to our customers, many of whom are here today, many more are watching this around the world. They really have also been with us at every step of the way. They've been with us at every step of our journey. They were there at the very beginning. They were there at our first launch. They're here at our second launch, and they'll be with us for many, many years to come, because now it's our turn. It's our turn to repay the faith that you have placed in us. It's our turn to deliver on our promises that we've made to you. And now with these 4 satellites in orbit, we really can do that. And what we've seen of the performance of the satellites so far has been tremendous. It's blown us away. It's excited us with the sorts of services that we can provide. And together, I know that we're going to be able to excite your customers and deliver services that your customers will be blown away by, and we can't wait. Collectively, the whole O3b team can't wait to connect each and every one of you. So, ladies and gentlemen, for all of the challenges that there are in the world, we really are lucky, I think, to be living through these times. JFK said at his inauguration speech in 1961, he said words to the effect of, none of us would want to trade places for any other people or any other generation. He said that in 61, and Here, 50 years later, I disagree with him, because I think the times that we live in today are truly exceptional, and we have access to technologies that weren't imagined, could not have been dreamt about 50 years ago. We have the world's information at our fingertips, and we have it, thanks to Google, we have it sorted in a way that makes it instantly accessible, and that's a magical thing. It's something that 50 years ago, if you'd said that that was going to be the future, that was stuff of science fiction, and it's now something that we take for granted. It's part of our everyday life. The internet is established as the key infrastructure that supports every sector of the economy. It's a fundamental driver of innovation, of productivity, and of economic growth. But today, this technology is not available to everyone, and we're going to change that. We're going to do our part in changing that. With these satellites in orbit, O3b and its customers will be able to deliver services to parts of the world that have never had access, and certainly have never had access to the kind of services that we're now going to be able to bring. O3b customers, some of them here today, are already delivering services in Kinshasa, a city of 10 million people, 8 million people in Papua New Guinea. We're live in Timor-Leste, we're live in Samoa and in the Cook Islands. But with these satellites we've just launched, we're going to be bringing those same services to more than 30 customers by the end of the year. From Colombia to Congo, from Somalia to South Sudan, some of the most populous countries in the world, Brazil, Malaysia, Pakistan, Indonesia, all of these places will be able to connect. And we're connecting these populations through mobile devices. The mobile internet is the future of the internet. Connections to the internet from mobile devices are growing 11 times faster than the population. Think about that for a minute, 11 times faster than the population. Mobile connections are being added 3 times faster than fixed connections. So the future really is mobile devices. Global mobile data traffic is doubling every 14 months. And imagine the impact that that has on the networks of our customers, and how having the kind of thick pipe connectivity that we can bring is going to make a difference to those networks. Plentiful and affordable backhaul really is the key enabler. It's the must-have. And it will spread the internet in large swathes of the planet that don't have access to the information today, don't have access to healthcare in the same way that we do, don't have access to education, and don't have access to opportunity. And as our customers reach out further and further in their networks, these new satellites and O3b will provide the critical infrastructure that our customers need to connect. So to finish, and to paraphrase another president, the time has come to reaffirm our enduring spirit, to choose a better history, to carry forward that noble idea that all are equal, all are free, and all deserve a chance to pursue their full measure of happiness. Thank you very much, everyone.
So, ladies and gentlemen, what a fantastic launch made by Arianespace, and what a great day for all of us. I think there is nothing closer in the life, closer to the birth of your children than launch of satellites. So congratulations to Steve and everybody at O3b. So your next 4 satellites are now in space, Steve, and your constellation is really taking shape today. It should have been done a little time ago, as you know, but we decided at TAS not to compromise with quality in order that you, O3b, be able to deliver the best level of services to your customers and continue to offer an extremely high performance to them. We are very pleased today for you. Regarding today's splendid launch, I would like to thank Stefan and all the team of Arianespace, and also Roscosmos, CNES, and ESA. Soyuz operated, like always, clockwork, and that's due to your skill, know, expertise, and experience. A big thank also to my TAS team in France and in Italy for their commitment. They have faced 10 difficult months, very loaded, There was a kind of race in order to have a slot of Arianespace beginning of July, and they did it. So I would like to thank all my team for this effort. So grazie a tutti, merci à tous, in Roma, in Cannes, in Toulouse. O3b is a groundbreaking project, and beyond groundbreaking projects, there are remarkable people. Greg, John, Steve, Brian. At Thales Alenia Space, we have been working with O3b for 7 years now, ever since Greg and Brian had technical discussion with TAS in order to optimize this system and pitched their concept for a telecom constellation in MEO. At the time, it was a novel idea, and look how successful it is now, like you put in the back of your T-shirt. We have created pioneering satellites which can quite literally change people's life here on Earth. Let's think of millions and millions of children who will e-learn, who will be educated through O3b system and satellites, and probably in 20 years, 25 years from now, there will be children that will become engineers and will make the next satellites of the future. And we are very proud of that. People are speaking a lot of innovation in the space domain with different projects that are, for the time being, only projects. I really do think that O3b is the major innovation of this first half of this decade in the space area. So Greg, John, Steve, and the team of O3b, the first 8 satellites in your constellation are now in space. And now, right now, as you know, we are building the next 4 for a launch plan end of this year, beginning of next year. So it has been a great, and it will continue to be a great pleasure to collaborate with everybody at O3b. You are so professional and so innovative. Right after the separation, my team in Cannes, through this device and probably using O3b satellites, told me that they have taken the control of the 4 satellites. They have already sent some telecommand to the satellites, and the satellites have reacted properly. So, Steve, I can confirm that we had the first cry from your 4 new babies. So. So to finish my speech, I would like to congratulate all the engineers of all companies, Arianespace, O3b, and obviously TAS, who have made this event possible. Every day in the world we see really silly things, and when we have a chance to witness an event like today in Kourou, we see that mankind can also be genius. Thank you.
Okay, so in fact, it's just the beginning of the summer here, because we will be back with Arianespace for ESA on July the 24th for ATV. It will be the last ATV, and I can tell you we will have many, many, many distinguished guests for this event, which will be a key event for Europe. And after, on August the 21st, we will go for another Soyuz, but this time for Galileo, and this time for the European Commission. So I want to thank all the stakeholders of tonight's success, and I want to thank by advance all the teams who are going to work very hard to make the next 2 launches of Arianespace for ESA and EC. Thank you very much to O3b, to TAS, and now have a good evening. Thanks a lot.
So it's mission accomplished once again for Arianespace. O3b's 5, 6, 7 and 8 are all heading out on their journey to their final positions in medium Earth orbit. Huge congratulations to everybody involved in today's launch. Everyone at O3b Networks. There's a replay of the launch earlier this evening. Congratulations also to the Russian and European teams for Soyuz for the perfect eighth launch from the CSG. All our friends at Thales Alenia Space for their skill and expertise, and well done to everyone at Arianespace for an excellent job. The best of luck now to all the O3b teams as your satellites fly to their final destination and you continue the next phase of your operations. Thanks for joining me here live at the Guiana Space Center. From me, Katie Haswell, goodbye.